Welcome to this explainer. Today, we're talking about the concept of productive laziness. Usually, we think we need to summon a ton of willpower and discipline to be truly efficient. But what if the secret isn't pushing yourself harder? What if it's simply about making the right action easier? We are going to see how doing less, or intentionally delaying work until the absolute last possible second, is actually the ultimate efficiency hack, both for us and for the code we write. Let's dive in. We've all been taught that procrastination is a bad thing, right? But what if being a little lazy was actually the secret to getting things done? Today, we are completely challenging that traditional idea. We don't always need raw willpower. Sometimes, by intentionally delegating tasks or even programming our software to literally procrastinate its own computations, we can reduce friction and see massive performance gains in the real world and inside our machines. Just to put this into perspective, think about the sheer amount of time we're talking about here. According to recent data from U.S. tech automations, small business owners who automate just their top 3 manual workflows recover 10 to 18 hours every single week. That's incredible. That is time previously drained by tedious things like manual data entry and follow-up emails, just magically handed back to them because they set up an environment that does the hard work for them. Here's how we'll unpack this today. First, we'll look at automating the boring stuff. Second, what is lazy evaluation? Third, eager versus lazy execution. And finally, caching and memoization. All right, let's jump right into section 1, automating the boring stuff, delegating repetitive tasks. The key to making things easier on yourself is choosing the right tools so you aren't relying on pure motivation to get through tedious tasks. If you've got a tiny team of 1 to 5 employees and just need simple app-to-app triggers, Zapier is incredibly fast and easy. But as things get a bit more complex with multi-step workflows like if X happens, then do Y, otherwise do Z, US tech automations becomes a much better fit. And if you're dealing with high-volume data, Make is definitely the way to go. The whole point here is to remove human repetition entirely. Let the tools do the heavy lifting. This idea is really the heart of Al Sweigart's famous guide, Automate the Boring Stuff with Python. I love how data scientist Hilary Mason puts it. She says, the best part of programming is the triumph of seeing the machine do something useful. Whether you're using a visual tool or a Python script to sort your files, you are practicing productive laziness. You're stepping back, reducing your own friction, and letting the machine step up. But what happens when we ask the machines themselves to be lazy? Let's get into section 2. What is lazy evaluation? The virtues of procrastinating computation. Over in programming language theory, there is this brilliant strategy known as lazy evaluation or call by need. Basically, it delays evaluating an expression until its value is absolutely, undeniably needed. Frameworks like Apache Spark or languages like Haskell use this all the time. They don't just eagerly process massive data sets the second you write the code. They conserve energy. They wait until you explicitly ask for the results. To actually pull this off, computer scientists use this fantastic little concept called a thunk. A thunk is literally just a zero-argument function used to delay evaluation. Think of it like this. Instead of writing a command and having the computer instantly execute it and drain its resources, you wrap it in a function. You essentially put it in a box. The computer knows the box is sitting right there, but it won't actually open it and do the hard work until you specifically call for it. So why do we even need this? Well, consider a snippet of scheme code trying to run a recursive factorial function using a custom if statement. Because the language naturally wants to do everything immediately, which is called eager evaluation, it tries to evaluate both the true and the false outcomes up front. And guess what? This immediately breaks the function. It sends it spinning into an infinite loop before it can even give you a single answer. It's trying way too hard. And here is where our thunk completely saves the day. By taking that exact same code and wrapping the outcomes in a lambda, which acts as our thunk, we delay the evaluation. We basically force the computer to wait and take a breath. It will only execute the exact branch of the if statement that is required exactly when it's required. It's a beautiful example of how productive procrastination can save a system from burning out. Which leads us perfectly into section 3, eager versus lazy execution, the performance trade-offs. Let's put these two side by side. Eager evaluation, which is the default in something like JavaScript, computes immediately. It eats up time and memory upfront. It's predictable, sure, and it's fine for small tasks. But lazy evaluation, it defers computation. It saves massive amounts of memory. You might feel a tiny initial delay the very first time you access the data, but overall, it's so much more efficient because it's only doing what's absolutely necessary. Let's ground this with a really cool real-world example from game development. Imagine you're building a digital card game, something like Hearthstone, using C#. You've got this one specific card, let's call it a mothership, and it needs to reference a massive database of related Protoss minion cards. If you use eager execution and try to load every single related card into memory the very second that mothership card is created, your game is going to suffer a massive memory spike. It's just too much friction all at once. But if you switch over to a lazy loading pattern, you fundamentally change the game's performance for the better. You significantly reduce that initial cost of creating the card. You only fetch those related Protoss minions at the exact moment a player actually requests to see them. This dramatically decreases CPU and memory overhead. You are only paying the computational price when it's absolutely necessary, keeping the whole system running smoothly. Now for our final concept, Section 4. Caching and memoization. Never repeat yourself. Memoization is the technique that makes lazy evaluation so incredibly powerful. It's basically about not repeating hard work. When a memoized function is called, the first thing it does is check a cache. If that cache is empty, it does the work, computes the value, and stores it. So the next time you ask for that exact same value, it doesn't do the work again. It just hands you the stored result. If you're calculating something complex, like Fibonacci numbers, this technique literally turns a painfully slow exponential calculation into a fast linear one. There is a slight catch, though. The main challenge with caching is making sure your saved data doesn't get stale or out-of-dated. We call this cache invalidation. If our Hearthstone game suddenly changes the stats of a card, our saved cache is wrong. The smartest way around this is event-based invalidation. When an event triggers, like card removed or stats changed, it automatically clears that specific cache. This ensures your data stays perfectly in sync without you having to go in and rely on manual intervention. And you know what? You experience this every single day when you're browsing the web. According to the Mozilla Developer Network, developers use lazy loading all the time to shorten the critical rendering path. Think about your favorite e-commerce site. It actively delays downloading the images, the CSS, and the JavaScript for your shopping cart until you actually click that cart button. By being totally lazy with the cart, they make sure the homepage loads instantly for you. So what's the big takeaway from this explainer? It's really a question you should ask yourself. Look at your daily workflows, look at how you handle your data, or even look at your code. Do you really need to push through and generate all those results right this second? Or, by setting up the right environment, the right automations, and the right thunks, can you afford to be a little lazy? Remember, you don't always need more discipline to be efficient. Sometimes you simply need to make the right action easier. Embrace productive laziness and watch your efficiency absolutely soar. Thanks so much for hanging out and learning with us today.